In this video, we are going to look at the equation f of x equals 3x to the fifth plus x to the third. And we are going to use that equation to decide whether or not the function f is odd, even, or neither. And we're also going to determine whether certain points lie on the graph or not. And we're going to do all of this algebraically. At the end of the video, however, we are going to graph this equation to check our work and see if we did everything correctly. All right, let's start with number one. F is odd if f of negative x is equal to negative f of x. That is the definition of what an odd function is. So in order to test if this is true, we need to find f of negative x, and we also need to find negative f of x. Let's start by finding f of negative x. So f of x, of course, is equal to 3x to the fifth plus x to the third. So f of negative x is equal to 3 times negative x to the fifth plus negative x to the third. Now, the general rule when we're dealing with exponents is this. If we have a negative number, like for example, let's just start with negative 2. If we square it, that would be a positive 4, because negative 2 times negative 2 is equal to positive 4. If we do negative 2 to the fourth, that would be negative 2 times negative 2 times negative 2 times negative 2. And a negative times a negative is a positive. So this would end up being positive 4 times positive 4. So this ends up being positive as well. As it turns out, if we take any negative number and we raise it to an even exponent, it will always be a positive number, right? And so negative 2 squared in this case is really the same as positive 2 squared, and negative 2 to the fourth is really the same as positive 2 to the fourth. Similarly, there is a rule if we have odd exponents. Let's think about what that would look like. Let's do the same thing with negative 2. But now let's raise it to the third power. Well, this would be negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4, but when I multiply that by negative 2, I actually get negative 8. Now, positive 2 to the third is positive 8. And so what we can conclude is that negative 2 to the third power is equal to negative 2 to the third. Okay? If we did negative 2 to the fifth, for example, we could go through the same process. We would find that that is equal to negative whatever 2 to the fifth is. Okay? So the general rule is if we have an odd number, such as negative x to the fifth, that will be the same as negative x to the fifth, which would be whatever that number is raised to the fifth power, and then we make it negative, or we change the sign. So with that being said, what that means is that when I simplify this, this is actually 3 times negative x to the fifth plus negative x to the third. And these negatives are really like I'm multiplying a negative 1. in each case, right? So 3 times negative 1 is equal to negative 3 x to the fifth. That's how that simplifies. And this becomes negative x to the third. All right, so that is what f of negative x is equal to when we simplify it. What is negative f of x equal to? Well, that would be negative, and what f of x is equal to 3x to the fifth plus x to the third. And so I'm going to distribute this negative sign, which means I'm really going to change the sign of both terms inside of that parentheses. This ends up being negative 3x to the fifth minus x to the third. Notice, again, this is f of negative x is equal to negative 3 times x to the fifth minus x to the third. And negative f of x is also equal to negative 3 times x to the fifth minus x to the third. So f of negative x is equal to negative f of x. So f is odd. So we know this is an odd function. Let's check if it's even. If f is even, if f of negative x is equal to f of x. Now we already know what f of negative x is because we have it right here. And we already know what f of x is because it's at the very beginning. It is equal to 3x to the fifth plus x to the third. Now, how do we know if these are equal or not? Well, let's just test some numbers. If you plugged in 0, these would actually be equal to each other, right? You would actually get 0 equals 0. But in order for these to be equal equations, they need to be equal no matter what x we plug in. So let's plug in x equals 1. Then this would be negative 3 times 1, which would just be negative 3, minus 1 is equal to 3 times 1, which is just 3, plus 3 times 1, which is just, oh, I made a mistake here. That should have been plus x to the third. I'm sorry about that. X to the third is just 1 to the third, which is just 1. So this means that negative 4 is equal to 4. That is false. So f is not even. F is odd, but f is not even. Almost all of the time, but not exactly all the time. Most of the time, almost always, f can either be odd or it can be even. It's very rare that a function can be odd and even. There are very few functions where that is true. And if it's the other option is it could be neither. But in this case, f was odd. All right, next, let's determine whether these points lie on the graph of f of x. And we're going to test 1, 4, negative 1, 4, and 0, 0. Okay, first let's test 1, 4. So if we're going to test 1, 4, we're going to let x equal 1. So I'm going to write in f of 1 is equal to 3 times 1 to the fifth plus 1 to the third, which is just going to end up being 3 plus 1, which equals 4. And this implies that f of 1 equals 4, so 1, 4 is on the graph of f. All right, so we know that is on the graph. Next, let's test, maybe I'll do it down here, test -1, +4. Again, what we're going to do is we're going to let x equal -1, and we're going to plug it in, and we're going to see, is the output +4? So f of -1 is equal to 3 times -1 to the fifth plus -1 to the third. This ends up being 3 times -1, because -1 times -1 times -1, 5 times is -1. And -1 times -1 times -1, 3 times is -1. This ends up being -3 minus 1, which is -4, not +4. So the point -1, -4 is on this function, but not the point -1, +4. So -1, 4 is not on the graph of f. Let's test the very last one, which is 0, 0. Let x equal 0. F of 0 will be equal to 3 times 0 to the fifth plus 0 to the third. And hopefully it's fairly obvious that'll be 3 times 0 plus 0, which is 0. And that implies that f of 0 equals 0. So 0, 0 is on the graph of f. All right, so we've figured out all these characteristics of this equation. Let's just double check that indeed this is the case by graphing these functions. Now let's see, where do I have, oh, I think I see where it is. So we're going to do x to the fifth. No, that wasn't it. It was 3x to the fifth. So 3x, why is that? Oh, that's why. X to the fifth plus x to the third. I'm going to zoom this out so you can see it a little bit more easily, what the graph looks like. First, we said it is an odd function. That means that it is symmetric around the origin. If I rotated this 180, it would give me the exact same graph. Now that should be fairly easy to see, that if I rotated this upside down 180, turned it exactly 180 clockwise or counterclockwise, I would end up with, and if the center of that rotation was the origin, then I would end up with the exact same graph. So that looks like that was correct. F is definitely odd. Next, I want to check that 1, 4 should be on the graph. I'm going to zoom in a little bit for this. So let's find 1, 4. That is correct. In fact, I'm just going to do this. 1, 4 we said was on the graph, and indeed it is. How about 0, 0? That is on the graph. That's what we said. And then we said 1, -4. No, I'm sorry. We said -1, +4 was not on the graph, and you can see that that is true. So all of our conclusions were correct. All right, so that's it for this video. I hope you learned something, and I hope to see you in the next video. Have a good one.